Most people are familiar with hydrogen peroxide solution that can be purchased at your local drugstore. It's used to disinfect minor cuts and scrapes. Sometimes if you use it on a scrape or cut that's too deep, though, it tends to sting quite a bit. Have you ever wondered why hydrogen peroxide comes in the dark bottle and why it has an expiration date? Hydrogen peroxide tends to spontaneously decompose. And so the reason for the dark bottle is to prevent hydrogen peroxide from being exposed to light, which would speed up the decomposition into water and oxygen gas, plus some energy. Now overall, this is a very slow reaction, and so over the course of several years, eventually, your bottle of hydrogen peroxide will undergo this decomposition, hence the reason for the expiration date. And because it's a very, very slow reaction, the energy that is the product of this decomposition isn't felt very easily. So when you pick up a bottle of hydrogen peroxide, it doesn't feel warm in your hands. But if we were able to, say, speed this reaction up, cause it to be able to decompose at a much, much faster rate, then we might be able to appreciate that energy or even detect it. Reactions that proceed slowly, like the decomposition of hydrogen peroxide, can be sped up through the use of a catalyst. In this case, the catalyst that we're going to use is 2 molar sodium iodide solution. We're also going to add a little bit of dish soap to our hydrogen peroxide. And the reason for that is, if one of the products of hydrogen peroxide's decomposition is oxygen, we'd like to be able to try and capture that gas so that we can test to verify that indeed that is the reaction that's occurring. So in the graduated cylinder, we have some hydrogen peroxide. As you can probably see, there's not a whole lot happening. This would be hydrogen peroxide straight from the bottle. No bubbles really, so it's not decomposing on its own. We're going to add a little bit of dish soap. And notice no real change. The yellow color is just the color from the dish soap. But again, no reaction, so even if we swirl that up a little bit to mix, no reaction yet. And then when we take the sodium iodide, we'll pour this in and see what happens. So now we have a very rapid decomposition of the hydrogen peroxide. And if we want to test to see if oxygen truly was generated, classic test is to take a lit splint, a glowing splint, and introduce it to oxygen. If it reignites, that proves that oxygen is present. So if we take our glowing splint, we see that it indeed does tend to reignite because of the oxygen-rich environment.